In this video, we're going to discuss Pythagorean theorem and its converse. We're going to use Pythagorean theorem to find a missing side length in a right triangle, and then we're going to be able to confirm whether or not a triangle is in fact a right triangle using the converse of the Pythagorean theorem. The Pythagorean theorem states that if you add the squares of the legs of the right triangle, it is equivalent to the square of the hypotenuse of the right triangle. Now, legs and hypotenuse are vocabulary words used for right triangles only. The legs are these two side lengths that are connected to the right angle, the 90-degree angle right here. And the hypotenuse is always opposite the right angle. So, when you are using the Pythagorean theorem equation, you can think about it as a squared plus b squared equal to the hypotenuse c squared. Now in this right triangle we have the two side lengths, their legs, 6 and x, and 13 is the hypotenuse. So x is the missing side length. We're currently missing a leg, so we need to solve for that missing side length. So what you need to do is plug in the existing information into the equation and then solve for the missing value. So first 6, we'll call it a, and it doesn't matter if you use that for a or for b because they're interchangeable. B squared, that's going to be our x over here. It's our b. This is our a. And then c squared, that's going to be 13 squared. So right now we're solving for this b value. So we need to evaluate the squares and solve for b. So 6 squared is 36. B squared remains the same. And 13 squared is 169. I'm still solving for b, so what I'm going to do is highlight it again to show you what I'm isolating. So if I'm solving for b, I need to isolate it. So on both sides, I'm going to subtract 36. That gets b squared by itself. 169 minus 36 is going to be 133. Now if I want to get rid of the power of 2, I'm going to square root both sides. So that's going to be b equal to... Now you can square root 133 and get a rounded answer, but in terms of Pythagorean theorem, we're going to be using exact answers for our final results. So we need to simplify the radical. In order to simplify a radical, you need to find a perfect square that goes into 133. Your perfect squares are 4, 9, 16, 25, 36, 49, and so on. But it turns out none of those actually go into 133, therefore it cannot be simplified. So as an exact answer, it'd be square root of 133 yards. Now that was solving for a leg. Number 3, this example, 9 and 6 are both the legs, and x is our hypotenuse, or c. It's across from that right angle. A and b are connected to that right angle. So when you write your equation, a squared plus b squared equals c squared, you're going to plug in 9 and 6 into your legs, and you need to solve for the hypotenuse. Now I'll highlight c here, show you what we're solving for. 9 squared is 81, 6 squared is 36, and c squared is still over here. 81 plus 36 is going to be 117. From there, to get rid of the power of 2, because we are solving for c again, I'll highlight that, show you that. We're going to square root both sides, and you get c equal to, again we're looking for a perfect square that goes into 117. there isn't one, so therefore, trying to find a perfect square that goes into 117, we think of 9. 9 goes into 117. You were to divide 13 times. And the reason we chose 9 again is because that is the perfect square. We want a perfect square in there because when you square root perfect squares, we get integers. So this ends up being 3 root 13. Because the square root of 9 is 3. I'll highlight to show you how those match up. 13 is not a perfect square, so therefore you cannot bring it outside the radical, so therefore it must stay inside. So the length of the hypotenuse is 3 root 13 yards. Now we're going to move on to the converse of the Pythagorean theorem. So they're going to give you 3 side lengths, and you have to determine, well, is it a right triangle, yes or no? Right triangles will always follow the equation a squared plus b squared equals c squared. If it's both sides are equal on the equation, and it ends up being a true statement, then yes, it is a right triangle. If both sides are not equal, therefore not true, then it is not a right triangle. Now remember that C is always going to be your largest side length. The hypotenuse is always the largest. And A and B are your other 2 side lengths. So in this case it's going to be 10 for C, and A and B are going to be 6 and 8 respectively. So 6 squared plus 8 squared equals 10 squared. This follows from A squared plus B squared equals C squared. So that's going to be 6 squared is 36, 8 squared is 64, and then 10 squared is 100. After adding 36 plus 64, you do get 100, and on the right side it is 100. These two numbers are equal. This makes this a true statement. And then you can write, yes, this is a right triangle. Now if you have 2 numbers that are not equal, making the statement not true, therefore it's not a right triangle. It could still be a triangle, just not a right triangle. But because these 2 numbers are in fact equal, making the statement true, it is a right triangle. Let's check this one out. We have root 6, root 7, and root 13. Root 6, root 7, root 13, the biggest number here is going to be root 13. So that's going to be your C. This is A, this is B.